Hello viewers, welcome back to my YouTube channel. Again in this introduction to computer vision course or computer vision using OpenCV within this course, we are going to proceed to our next session where I'll be showing you how to determine the image dimension like width, height and channel of the image, whether the image is a black and white or a colored image like it is having red, green and blue channels, all those things. And what is the dimension like height and width of the image. Okay, so for that we'll make use of NumPy library. Okay, to understand more on NumPy, I will provide you a link in the description where you can read about more on the NumPy, how we can use this library for various purposes. Okay, so here I am importing NumPy library and then printing the image shape. Image.shape will give me these three values where it results in a tuple. This tuple will contain height and width as well as the channel of the image. If the image is colored, it will have three channels. If the image is black and white, it will have just one channel. Okay, either 0 or 1. Okay. So let's print height, width, and depth of the image that we have imported. This was the image that we imported earlier. This was the image that we imported earlier, right? So now here we have printed height, width, and depth, which is from this tuple image.shape tuple, right? So 0, 1, and 2 indexes will give height, width, and depth respectively from that image. Now here we have refined our image show function further to show the image by maintaining the aspect ratio so that this image will not get larger and out of the Google Colab notebook. Like if it's a very big image, it will be harder to show within the Google Colab. So we are just maintaining aspect ratio based on the height and width and height. And then we will show the image maintaining the aspect ratio. And that aspect ratio is based on the size sets. Okay. So the more we increase the size parameter, the more bigger image will be shown in the Google Colab. If we reduce it, the image will be reducing in size within the Google Colab while showing it. Okay, so let's define this function. Okay, and then the previous image we are printing using size sets. Okay, like that. Let me show you if I just increase it to 8 and then again define this function, then again run this show image. Here you will be seeing a bigger image than the previous, right? So that's the advantage of creating this function, okay, custom function to show the image. This will maintain the aspect ratio of the image while we are working in the Google Earth. Now, in the next section, how we can grayscale the image or just turn it into a black and white image, right? So for that, we have something called CV2, CVT color, like computer vision function, right? CVT color, where we'll pass the actual image object and then convert into color image to gray, right? So BGR or basically blue, green, red channels to gray color channel. Okay, so like out of color channel or gray color channel, and it will show me the gray image. By calling the IMShow function, we are setting the title of the image as grade image. Then we are passing this grade image object after conversion from color to gray, right? And then we'll run it and it will show us a gray image. Now, in the next section, once we try to see the dimension of this image, we'll only see width and height. and there is no channel information because gray image will have no depth or channel information. Next, if you want to just show the different channels like gray, red, green, and blue from each of from that colored image, then we can split it using NumPy array. Here we are splitting using CV2 function dot split, and we pass the image, and it will create these three different color spaces: blue, green, and red. So CV2 follows blue, green, and red channel, not RGB but BGR channel. Okay, so it will unbind like the BGR. Okay, now we are creating NumPy image placeholder, or you can say template, with 0 values, and within that, that 0 matrix basically. Okay, and we'll pass it to this image show function, where we'll just keep other values 0 from our colored image and only keep the red channel uh, pixels as is. Okay, similarly for green image, if you want to keep only the green channel, we keep blue and red channel values to 0. Similarly for blue, we'll keep the blue pixel values or array values as is, and set the green and red values to 0 using this NumPy matrix. Okay, 2D matrix. Once we run this code, it will just show us red, green, and blue channels one by one. Okay, so this is how we can split a colored image to these three different channels. Okay. In the next section, showing all color spaces. Okay, so there are these color spaces within OpenCV. We have more than 140 color spaces. Okay, within OpenCV, I have just kept some common color spaces. Okay, and we'll be running through this color spaces one by one to show the image. Okay, how they look like once these color spaces are applied to our original image. So here you see, okay, I have written a loop function to I have written a for loop function which will iterate over these color spaces and try to apply this color spaces one by one. Okay, here we are calling OpenCV read function to read our original image and then convert it to the color space for that instance, and then show that image in our Google Colab notebook. Okay, so let's run this. Let me just scroll down a bit and let's run this. Now after running this code, you see first is converting it to HSB, YUV, HLS, lab color, LUV color, YCR and CB color, XYZ color, and gray image. So if you want to know what all these color spaces indicate, I'll provide that link as well in the description. You can read about these color spaces in detail, like what all these HSB, YUV, HLS mean, right, for each color space. Okay. So now let's see from the starting. So HSV color looks like that one. Okay. Then we have YUV color. Okay. There are also some numbers or associated with these color spaces. So instead of this color space name, you can use those numbers for that color spaces. So here you see the title being shown here is basically a color space number and not the color space name. Okay. So these are some constant values for each of the color space provided in OpenCV library. So these are different color spaces that we saw. Now, if you want to see how we can merge three different color spaces that we created above, right? Blue, green, and red color spaces. Just before this section, we created these three different photos out of our colored photo. Now, if you want to merge and get the original image out of these three channels, we can do that as well by using this piece of code. Okay. Here, we are creating a merged image object and we are calling a merge function from OpenCV library, and the channel information in OpenCV is BGR. So we are merging all these three uh, two-dimensional arrays, okay, and then it will just show us the merged image, or basically will convert it to original colored image. Okay, so let me run this code.